Thank you for having me. I'd like to talk about ocean climate system and its effect on the marine resources. And in this particular talk, I'd like to focus on the skipjack tuna catch in the Micronesia. And this is where one of the KIOST research center is located, the Chuuk State. So, in the tropical Pacific Ocean, this kind of ocean climate system and its changes are very well known. In this figure, this box is on upper ocean, and colors are sea surface temperature. And in the eastern side of the tropical Pacific Ocean, we have cold tongue, and to the west, we have warm pool here. And during the El Niño period, this is the sea surface temperature anomaly, so we can see large SST anomaly to the east. And if you look at this same field in the SST sense, not in the anomaly sense, you can see the Western Pacific warm pool is expanded like this. So this kind of ocean climate system is known to affect the Western Central Pacific fisheries here. And if you look at the fish catch in this region altogether, these are the 4 major species, and one of the dominant species is skipjack tuna here. So there was a previous study to explain the relationship between the Western Pacific warm pool expansion or contraction and skipjack tuna population in this region. So in these 2 figures, contours the mean SST, and dots are skipjack tuna catch, and they inhabit the epipelagic layer, so they follow the SST, the warm pool region. So during the El Niño period, you can see the warm pool is expanded, so the mean SST contours are expanded toward east, and also the skipjack tuna catch was expanded toward the east. So in this study, the beauty of this study was that they had this kind of spatially well-distributed skipjack tuna catch data set. But this kind of well-distributed data set is not available, not easy to obtain. So we looked at the tuna catch in its EEGs. So in the western side of the tropical Pacific Ocean, there are many islands, and this is about the latitude of the convergence zone between the Western Pacific warm pool and the cold tongue. And to the west of the convergence zone, Micronesia is located here, and there are many other islands to the east of the convergence zone. And if you compare the skipjack tuna catch in these different locations, Micronesia has the largest number like this, and there are other islands. And if we focus on the recent 20 years of skipjack tuna catch, and they exhibit inter-year variation, and there should be a correlation between the Micronesia and the other islands if this is related to the convergence zone. So these are our 2 main questions. Is there a statistically significant relationship between the ENSO-related environment and skipjack tuna catch in the Micronesia? And if this answer is yes, then we would be able to see the negative correlation between the Micronesia and the other EEGs to the east of the convergence zone. And if these are all yes, then we can apply a simple statistical method to predict the tuna catch because the ocean environment variables are available. So, and we would like to find the most appropriate variable to predict the tuna catch. This is a list of data set we used. And by using the data set available, the very first simple analysis we can do is making a correlation map between the ocean environment and skipjack tuna catch. And this is based on the 23 years of data set. And these 2 are correlation maps. Upper is with the 50-meter upper 50 meter temperature, upper 50 meter mean temperature, and the lower is for the salinity. And Micronesia is located here, the bold box region here, and this is the equator, and this is 160 degrees east. So these two maps look not so well organized maybe, but we can see statistically significant correlations here and there. These boards represent the 0.6 correlation coefficient. And these all look like ENSO related. So based on this, we also compare the skipjack tuna catch in the Micronesia and the other EEGs to the east of the convergence zone. So here in the time series, this is the 23 years, and red is the Micronesia, and black is the sum of all the other EEGs. So there is a negative correlation between them, and if we just pick up Micronesia and Kiribati, that's the second largest skipjack tuna catch EEG, then we can find more significant correlation between them. So we can go to the next step. So our main goal is to find the best predictor for the tuna catch. And this is a summary of the statistical relationship between the tuna catch and the ocean environmental variables. So we tried many different pairs, and these are some examples. So in each plot, x-axis is the ocean environment. It can be temperature, it can be salinity. Temperature is colored in red, salinity is colored in blue, and y-axis is the tuna catch. And these numbers are correlation coefficient between them. So we tried 5 meter temperature or 5 meter salinity, upper 50 meter variables, and upper 100 meter variables. And the conclusion is that generally salinity can be a better predictor than the temperature, and upper 50 meter salinity would be the best among them. And we have some discussions to explain why the near surface salinity would be a good predictor. In short, during the El Niño period, this is the vertical section of the temperature and salinity from west to the east. So these are the anomaly patterns. And salinity anomalies are concentrated. They are larger in the near surface layer. And if we make a prediction, the anomaly is important to make a prediction. It can give some good scatter dots. And also, to make a prediction, simpler the better. And near surface information is, we need some more reliable information to make a good prediction. So we picked up this near surface salinity, and this some analysis, this some forecast actually. So we have 23 years of tuna catch data, and we just used the first 20 years as a training period. And these last recent 3 years are the result of the prediction. So black is the observed tuna catch, and blue dots are the predicted values. So when we use the 20 years of training period, they agree very well. And if we use the 15 years of training period, there are some differences. So yeah, this was another try. And so ocean environment variables are provided as a forecast, predicted variables. So we have ENSO index prediction result, and also we have the spatial patterns of the temperature and salinity. So we can actually apply to predict the tuna catch by using these variables. So going back to the questions we had. So we showed some positive results from the tries, and we can suggest the upper 50 meter salinity would be an appropriate variable for the tuna catch prediction. Thank you.
Thank you.